This is Aarhus on the east coast of the Danish peninsula. This important port city is the capital of Jutland. It's a region known for the major First World War naval battle which bears its name, as well as for the many IT companies which have set up here in recent years. Peter Møller-Jensen is the director of OSIS, a major environmental project which should soon make it possible to get a clear and precise picture of marine pollution on a 24-hour basis.
OSIS stands for Oil Spill Identification Sensor, and that was a working title for a project we were puzzling with in the late 19s. You saw governments putting in place regulation to protect sensitive marine areas, and that would require heavy surveillance, and there was no means of doing that then, and that was why we decided to provide a system which could do that.
This is a 3D illustration of the technology. Developed together with the Danish Navy, the Danish Environmental Protection Agency and the European Commission's LIFE programme, OSIS will be able to survey special areas in real time.
A special area is a sensitive marine area where you do not have a lot of exchange of fresh water. Like if you look at the Mediterranean, you don't see a lot of water coming in, so it takes a long time to recycle the water. And in all those areas, pollution is quite critical. And therefore, those areas have been ratified as special areas, which means they are facing complete different scenarios for oil spills.
Techniques such as satellites and air surveillance are too costly and too imprecise to cover special areas 24 hours a day. In order to monitor but also circumscribe any eventual accidents, the environmental services really needed a complementary system able to operate day and night and in all weathers.
Et hjælpemiddel til at se olien om natten vil jo klart være en fordel. Ellers har vi kun en projektør og hvad vi umiddelbart sådan har, der kan lyse i vandet lige umiddelbart omkring skibet. Altså jo hurtigere vi får en melding om et udslip, jo hurtigere kan vi gøre en indsats og begrænse en eventuel skades omfang.
Offshore structures and ships are the main sources of the 500,000 tons of hydrocarbons spilled into the sea every year. It is indeed time to reinforce surveillance. So far, current systems for identifying polluting slicks could only pinpoint the accident itself.
If you look at oil, you'll have 90% of the volume will be in 10% of the surface area of the oil slick. That means if, for example, you want to clean it up, you want to go to that heavy slick in the first place and not to the thin areas. The goal is to provide a technology that can enable a precise estimate of the surface area and the volume in an oil slick.
To allow this high-precision process to work, since 2000, OSIS engineers have been developing entirely new sensors designed to be installed on ships and offshore structures. OSIS can precisely determine the volume of hydrocarbon slicks in the marine environment.
In the OSIS sensor, we use two microwave instruments for measuring the oil. A radar for measuring the surface area and the location of the oil, and a radiometer for measuring the oil thickness. The radar transmits a short pulse and receives the echo, and then we are able to locate the oil. And the radiometer measures the natural thermal radiation from objects, and the higher the radiation, the thicker the oil. And by combining these two sensors, we are able to calculate the volume.
OSIS has been essentially designed for 3 applications and can be operated independently in 360-degree mode, angular mode and spot mode. As illustrated, the 360-degree mode can be used to identify oil leaks on offshore structures in a totally automated way. Used on commercial vessels, the angular mode enables the sensor to be used as a rear-looking instrument that detects oil leaks from ships, and the polluters are traced by AIS transponders, which are now obligatory on all commercial vessels. Finally, the sensor can be used as a forward-looking instrument mounted on environmental vessels, and the volumetric positioning of oil slicks allows them to be cleaned up much more efficiently. In practical terms, the data concerning the polluted zone transit via this identification software. If there's a problem, sensors immediately communicate the information via satellite and the internet.
All data is recorded on an offshore location, and it is all transformed and transmitted onto an onshore central-based server, from which you can get the information and visualize it on an on-site location with the operators sitting nearby. Or you can do reports and you can present it to clients and customers.
This new instrument should allow marine pollution to be identified, traced and cleaned up, thus applying in practice the regulations and protocols ratified by the states. It is, however, not certain that the owners of ships and fixed installations will voluntarily install such equipment. This may require an obligatory approach. When all ships and fixed installations use such equipment, the marine environment will then be much more effectively protected against oil spills.